When you see a ball bounce, you have an intuitive sense of its elasticity. You can tell how thick a liquid is just by watching it pour. Humans are great at this, but can artificial intelligence do the same? Welcome to Summarize Science, where we break down the latest research. This paper investigates a fascinating question. Do modern AI video models actually understand the physics of what they're seeing? To find out, the researchers focused on 3 specific properties that you can only see through motion over time: elasticity, viscosity, and dynamic friction. First, they had to create a brand new dataset called visvid because nothing like it existed. It's filled with thousands of computer-generated and real-world videos showing objects bouncing, liquids flowing, and objects sliding. Each video is labeled with the precise, ground truth physical value, which is crucial for testing the AI. They set up a contest between 3 different approaches to see which could best infer these physical properties. The first contestant was an oracle method. Think of this as an expert system that is specifically programmed to look for the key visual cues, like tracking a ball's height or a liquid's spread. It represents the best possible score you could get just from analyzing the video's pixels. The next contestants were the big, pre-trained video foundation models, the kind of technology that powers video generation and analysis tools. The researchers wanted to see if these models, trained on vast amounts of general video data, had accidentally learned some intuitive physics along the way. Finally, they tested multimodal large language models, which are like chatbots that can see. They literally showed the videos to the AI and asked it questions about the physics. So, what were the results? Unsurprisingly, the expert oracle model performed the best, confirming that the information is indeed present in the videos. More interestingly, both the generative and self-supervised video models performed very well and quite similarly to each other. This suggests that in the process of learning to understand video, these massive AI models are genuinely developing an implicit understanding of physics. The language models, however, were the weakest performers. They struggled with the synthetic, computer-generated videos, but did better with real-world clips, and their performance could be significantly improved with better instructions and examples. This indicates they might be relying more on recognizing familiar objects and situations rather than analyzing pure motion from first principles. All of the models found friction to be the most challenging property to estimate correctly. So, let's recap the important points. Researchers showed that modern video AI models have started to learn an intuitive sense of physics like elasticity and viscosity just from watching videos, which is a major finding. However, they are still far from perfect and lag behind specialized systems, particularly when asked for exact numerical predictions. And language-based models seem to think about physics differently than pure vision models. This work is a critical step toward creating more physically grounded AI. Imagine future robots that can predict how an object will behave before touching it, or AI assistants that truly understand the physical world they see through a camera. It's a challenging road ahead, but this research provides a vital map for the journey.